So, hi everyone, and welcome to this event on the evolution, challenges, and future perspectives of analytical chemistry. Thank you very much for taking the time to join us today. My name is Xavier. I'm the course advisor for the online and part-time Analytical Chemistry and Measurement Science course we offer at the University of Manchester. My role is to help you with any question that you might have about the course and guide you through the application process. But today, I'll be mainly facilitating the session, and if you are interested in the field of analytical chemistry, this event is a rare and excellent opportunity to get valuable insights from international professionals on the current issues and potential future paths of analytical chemistry. I'm very pleased to be joined today by an amazing panel. We've got with us Roshila, Alta, and Alexandra. Unfortunately, Vanshni, who was supposed to join us from LGC, had to cancel. However, we are in very good hands, and I'll invite our panel very shortly to introduce themselves before we move on to the discussion, which will be led by Roshila. After the discussion, we will have time for a Q&A session, so I invite all participants to use the Q&A function or the chat box to interact with the panel. Please feel free to ask any questions during the discussion, or if you prefer, later on during the Q&A session. Actually, I invite you all, audience, to add a message right now in the chat to let us know who you are and where you are joining us from, so we have a better idea of who has joined us. So, if you're watching the recording back, and if you have any questions, please feel free to contact me at studyonline@manchester.ac.uk. You can see the email address at the bottom of the screen here. Don't hesitate to email me. I'll be happy to help. I think that's it from me now. Roshila, as you are the course director for our Analytical Chemistry and Measurement Science course, would you like to start introducing yourself?
Thank you, Xavier. Hello, everyone. I'm Dr. Roshila Mudli, the Program Director for the Analytical Chemistry and Measurement Science course, which is part of the Transnational Education Framework at the University of Manchester. I'm excited to welcome you all to today's webinar, including our esteemed panelists, who are some of the brightest minds and thought leaders in the field of analytical chemistry. So welcome to everyone and welcome to our panelists. Thank you.
Thank you, Roshila. Alta, maybe you want to introduce yourself next?
Yeah, good afternoon, everyone. Firstly, thank you for inviting me to be part of this panel. I'm looking forward to not only share my experience, but also to learn. There's always opportunities to learn. So my name is Alta Ferreira. I've actually studied and did my PhD in organic chemistry, worked a lot in homogeneous catalysis. I worked for more than 10 years in the Fischer-Tropsch Technology Research Department in Sasol. And for the past 5 to 6 years, I've joined the analytical chemistry sciences within Sasol. And what our team does is we support both operations, research, and then we do a bit of our own research in analytical chemistry.
Thank you, Alta. Thank you. And Alexandra, if you want to.
Yeah, hi, I'm Alexandra Hinch. I'm working at Dow Chemistry in Stade. I studied chemistry in Hamburg, and yeah, my bachelor thesis was about mass spectrometry. But yeah, for my master and my PhD, I went more into physics. Here I concentrated on investigations of semiconductor nanoparticles via confocal laser microscopy. But after my studies, I decided to learn more about GC and LC and started working in the R&D department of a service laboratory in Hamburg. And 2 years later, in 2021, I thought of a new challenge and switched back to Dow, where I also did an apprenticeship earlier. And here, my job now is a site analytical specialist. Yeah, but what does it mean, site analytical specialist? So I do the technical support for our 8 site labs, yeah, regarding nearly all lab issues, like, for example, new devices, new methods, improving existing methods, repairing devices, optimizing processes, qualifications, validations, all this stuff. Yeah.
Great, thank you very much, Alexandra. So we're going to go to the conversation, which will be led by Roshila, and so I will stop sharing my screen and leave the floor to Roshila. So.
Thank you, Xavier. Once again, I'd like to extend a warm welcome to our panelists. So let's now dive into the fascinating world of analytical chemistry by reflecting firstly on its evolution. Analytical chemistry has radically transformed from its humble beginnings to today's cutting-edge technologies. Alta, I'd like to start with you. Could you share some insights into the key milestones and breakthroughs that have shaped the field at Sasol, South Africa over the years?
Yeah, so when I reflected on it, there's a dual evolution for me. The first one is in chromatography, GCs, and the whole evolution around that. So for us, the fused silica capillary system greatly increased the application of high resolution GC. And within the petrochemical field, the separation of chemicals is one of our key businesses. So I think the first thing I want to mention is the impact that analytical chemistry has on business. So my answers and my perspective will always come from a business perspective as well. So the evolution of GC with regard to the fused capillary systems, the compactness of the equipment, the ability to do GC, multidimensional GCs, also greatly advanced Sasol's opportunity to produce, to bring more products in the market from our Fischer-Tropsch process. It also had the revolution of doing high temperature sample prep, for example, within our wax side, also helped us to basically produce more chemicals, develop more of our waxes into different fractions, cosmetics, that type of application. And then on the flip side of that, the whole evolution of material science. So anything to do with X-ray diffraction, synchrotron, mass microscopy, any study on nanoscale helped us to develop our cobalt gas to liquid catalysts, and that's one of our core technologies. So I would say from a Sasol perspective, on the flip side, what you call separations technology, GC, and then on the other side, more the nanoscale analysis of or characterization of materials, which really enabled us to fast track our catalyst development within Sasol.
Thank you, Alta. Firstly, for the perspective on Sasol and also the business perspective. So the synergy between advancements in instrumentation, as stated by you, Alta, methodologies and interdisciplinary collaborations have been key to the evolution of analytical chemistry, driving innovation and pushing the boundaries of scientific discovery. Now over to you, Alexander. How have these advancements contributed to the evolution of analytical chemistry at Dow?
So, yeah, I would say that I haven't been in this job too long to have experienced real milestones in chemistry or analytics. I would say it's really difficult to find a real definition for it. But yeah, from my point of view, great breakthrough is definitely the digitalization and automation. Or yeah, let's say the trend that a lab technician is less and less active in the lab. It sounds funny, but yeah, in the past, you usually spent most of your working hours in the lab directly in front of your devices. But yeah, nowadays, more and more office space is needed, or space for computers and monitors. As a lab technician, for example, remotely controls this equipment, uses an automated sample prep, or makes evaluations via software at a desk and so on. And it's a really challenging, to that, because you also need the right infrastructure. And when you have old labs, it's not so easy. You also need a lot of special trainings, and also, let's say, the willingness and the acceptance of the lab staff to learn and implement those techniques with all their rapid changes. And when we go back to milestones and breakthroughs, I think this can be really individual and is totally dependent on the point of view and the analytical field where you are working at. So the individual needs, the challenges, the goals. So when you see my career was, so the university, then R&D department in a service laboratory, and now the industrial environment, and it's really different. So when you have the research and development in the university, it's always about research of completely new things. You want to have new discussions, new want to point out new possibilities, new directions, and so on. And when you then compare it to the R&D department in the service laboratory, here the focus is not only on innovation itself anymore, but also on customer needs, coupled with achieving profit for your company, which in turn suddenly kind of limits implementations and availability of resources. And then in the industrial environment, it's all about quality control and process monitoring for profit. And here the focus is on time, reliability, and robustness. This is really important. This means, putting theory into practice, but not only practice, but also useful and profitable practice. So it's a complete opposite of R&D. And that's why I think milestones, have really different meanings for everyone, can be kind of everything.
Thank you, Alexandra, for that insight into the differences, I suppose, between academia and industry. Integrating automation and robotics in analytical processes, as you've said, has greatly enhanced efficiency and accuracy in data collection. And so these advancements have propelled analytical chemistry forward, paving the way for innovation and research and practical applications. So now over to you, Alta, because Alexandra has touched on this. Can you elaborate on how automation and robotics have advanced analytical chemistry in your industry, maybe in Sasol and worldwide?
Yeah, so I would say robotics on our side, not as much. Automation, definitely in terms of just the throughput of analysis. I think that's one of the things where within the industry, that is one of the key advancements where you can actually do multiple analysis over a short period of time, as Alexandra said, without intervening. But I think for me, automation in the Sasol context is really around online analysis. So where we have the ability to, so one of the systems that we are doing research on is to have use Raman online, where you calibrate it with a GC in the background, and then you can do multiple analysis on the real life system continuously to give that real-time data. And I think it's true what Alexandra said in terms of skill set. So if you have the wrong skill set within your laboratory or operations, then it's rather difficult to implement. So to answer your question, that perspective, that's quite a challenge within Sasol. But I do see that the more automation can come in, again, the best it is for business.
Mm-hmm.
Yeah, so it's in Sasol's context, I think we still have a lot to gain within that.
So kind of to streamline workflows and increase throughput, handle large volume of samples, reducing human error and variability, and so on.
Yeah, and that specifically we try to address with having chemometrics models based on spectroscopy type of techniques like Raman. And then you can really automate basically your whole process. You can link your process control parameters. And I think that is the part within the petrochemical industry where analytics is really aiding basically operations without having a process controller to step in and change temperature controls, etc. You can automate that whole system by using a spectroscopy technique that's really robust with regards to temperature, pressure, etc. And then link that back to your process to say, let's say within the petrochemical industry, you've got fuel specifications, you've got your system, your stream coming in, and you can actually have your spectroscopy within the stream, your chemometrics in the background, and it can actually tell you for this fuel specification, increase the temperature or change the feed, etc. So I think that's where, within our context, automation is really making a difference.
And how has this impacted on the human resource, besides freeing them up to engage in other activities? In terms of the staff requirements, how has automation, robotics, and AI impacted on human resource? And what type of training or collaborations do you provide? How have you capacitated your staff so that they are keeping abreast of the latest trends in technology? This can be either.
No, it's a very good question, and that's why I reflected on your course material. So obviously, it enables us to basically upskill our staff to focus on more advanced research rather than just focusing on doing another GC analysis that takes you 4 hours that you can do with a Raman analyzer automated in the background. So it actually frees up, I think, a lot of our staff to be able to upskill them. And with that upskilling, you can actually then focus on future technologies. You can focus on the analysis, the advanced analysis, for example, in environmental compliance, where you really need to go down to stretching your detection limits. For example, with us, sulfur emissions is currently a very hot topic at the moment. So we can actually shift our resources to that aspect. So it's upskilling, people get more meaningful work. Yeah, it's a win-win.
Thank you. Alexandra, would you like to add to that?
Yeah, I would say just back to the digitalization and the real work of the people. So I think we have, as I mentioned, 8 labs here, and 6 of them are really process labs. They are directly in the located in the plant, and they do the process analytics. And here it's for us, it's important to have less errors, just for typing samples and such things, or weighing things and so on. So we try to automate this. So this is let's say really simple first. We do not need really special and exclusive techniques for the processes. So here it's more to get less error in the work. So this is why we do this automation and digitalization. And then we have also 2 environmental labs. And here it's really important because of all these new requirements from the authority and so on. Here we need really better sample preparations because the limits of detection and quantification are lower and lower and lower, and there are always new requirements. So we have to be faster and more exact with our values. And here it's so the lab staff, then it's not that they do not have any work anymore. So because there are so much more samples, and we try to find a way to make it more accurate and to come against all these new requirements from the authority. So here it's really that from 50 samples now we have 100, and next year we have 200, and it's always more. So we need then here an automation.
Thank you, Alta and Alexandra, for your insightful reflections on the evolution of analytical chemistry. As we consider our progress, it's important to acknowledge that there are challenges that lie ahead. In today's fast-paced and dynamic world, analytical chemists face many obstacles, from sample complexity, as you've just stated, to regulatory constraints, as Alexandra has stated. At the same time, there's a need for sustainable and environmentally friendly analytical methods, because nowadays everything is about green chemistry and the circular economy, and practices to minimize resource consumption, especially if you're talking about Dow with agrochemicals and Sasol with petrochemicals, to reduce waste generation and to mitigate environmental impact. Alexandra, firstly to you, can you tell us what challenges you see facing analytical chemistry today and how these have impacted our ability to advance in the field?
Yeah, so as I mentioned already, you also, so at the moment, or yeah, we have the regulation topic. So, and at the moment, unfortunately, industry is most of the time behind upcoming regulatory requirements, we must say, or new questions from customers. So we definitely need to learn to react fast when it's needed, and yeah, to more anticipate future changes. And therefore, I think a strong connection between all disciplines we have, so analytical, commercial, sales, R&D, is really needed to be capable to deliver viable solutions. And yeah, the environmental tasks is more and more in focus. And as I mentioned, there are steady changes in regulatory requirements, new requirements, lowering current limits. So it's really hot topic, and this is really challenging for us. So also when you think of new devices, new techniques, and then also just the space in our lab where to put all the new devices and the new techniques and so on, we really have to find solutions for this. But of course, there are also smaller obstacles, I think, in analytics that are not so really in the focus, but or they seem really simple, but for us it's not so simple. Is, for example, the availability of chemicals. So in the latest, we experienced more and more problems with delivery times or discontinuing necessary chemicals. And we really had to struggle with issues where we nearly couldn't perform our analysis due to such availability problems. So it seems so simple, but it's really problematic. And as I mentioned, also the price trend regarding chemicals, devices, consumables, it's so exploding. I do not have to mention the crazy price trend regarding helium and its availability. So there are current changes, and you have to react. So, and it's not you have your method and your analysis and everything's fine, then there are also these small things, and you really have to struggle with that. So at the moment we try to go away from helium to all hydrogen or nitrogen for the GCs, and try to find more alternatives for chemicals, to have a backup plan when there is again a high delivery time and so on.
So to continue from what you're saying, Alexandra, on the price trend, how has that impacted on greener analytical techniques, or the moving forward towards green chemistry for a more sustainable and resilient future? Do you see that perhaps if a technique is greener, it's more expensive? What has been your experience in this regard?
Difficult to say. I think I would not say that it's always than a higher price than, or it's more expensive than. But I think it's the normal trend, of course, and it makes it more difficult just to think in other ways. So when you have your technique and everything is working, and then you see that you want to have a new device, but you see there are new costs, and so then it's a question if you do or you take the change. So I think it must be more attractive for the industry to go these changes. So.
Thank you. And Elta, would you perhaps like to contribute on greener analytical techniques at SASL? And is it the bottom line that is more important, or environmental impact and mitigating for all of that is required?
Yeah, so it's interesting to hear that between Dow and us, we struggle with the similar things. So with us, we also had to relook the way we look at liquid helium and what we use it for. We do need it for our advanced techniques. So I think that's a challenge. Looking at greener on an analytical front, I think we haven't even started to scratch the surface with regard to that, because we have to support our industry in terms of them becoming greener. So I would say the focus in the analytical side is more to enable the rest of SASL to become greener. So with our greenhouse gas emissions, how can we support and analyze to those low levels? How can we, and that's perhaps one of the points I want to make, is how can we, from our fundamental understanding and our analytical understanding, make a contribution to the environmental side within SASL. And that's what I've seen the most over the last 6 years, is how analytical chemistry can actually steer how you do your greenhouse gas emissions reductions within the company itself, when how the teamwork enables that reduction, and how an important role analytical chemistry plays in that. But looking at making the techniques itself greener, not currently at the forefront of our way, just because we want to make our business greener.
I think this is a good point. So as you mentioned, so it's more the industry, so the whole processes and so that gets more greener, and in analytic it's not so present. And I think in the analytic it's more the safer way to work. For the employees to have, when it's possible to substitute chemicals, that it's safer for them to work with it and so on, or use less chemicals and such things. So this is, I think, more important in the labs.
Perhaps this is where maybe robotics, AI, and automation will play a key role to free up human resources so they can focus on technologies that are a little bit greener and requires that kind of insight. So Alta, we know that advances in instrumentation, data analytics, and AI, as I've just mentioned, offer new capabilities and insights. But keeping pace with technological advancements and harnessing their full potential requires ongoing education. It's something that we have touched on a little bit in terms of training of staff and adaptation. How has your industry responded to these challenges? So basically, how have you trained your staff to move forward with the technological and cutting edge advancements that we see?
Yeah, so I think the skill requirement definitely shifted. So in the past, we really were focused on really employing people with one skill. We're looking now at multidimensional skill sets, specifically with people handling large data sets. So we've got a statistical team that works closely with us, but the requirement currently is actually to employ more multi-skilled people. So we had an interesting conversation this morning around, if you think about people with a physics background, it's actually people that's critical within an analytical space, because most of the analytical equipment are based on physics. And then together with that, if you can incorporate then someone that can have that large data set mindset, and how you can automate, for example, XRD analysis, where you can just automate the refinement of that, you can actually alleviate a highly skilled person to look at the greener chemistry, like you said. but we still have a way to go.
And if you're automating the process, then you have huge amounts of data and large data sets, and you need to draw meaningful insight from that. So are you now looking at employing maybe data analysts?
Yeah, so we do have data analysts. We have a data analyst, a digitalization team that helps us with writing programs. We recently had a person helping us to basically automate and standardize our electron microscopy data on our catalyst, where you don't look at it individually, but from a QC perspective, you input the data and you make sure that it's interpreted in the right way, because otherwise you have that human factor that looks different, and you can't just have that subjective interpretation of, let's say, high resolution TEM images and what you make of your catalyst. So definitely shifted us, definitely in some pockets of, let's say, where we do the research side, it's more pronounced. Compared to other places where we actually are looking at what do we do with these large data sets. I think the one point I do want to make is you're only as good as the data that you get. So one needs to be careful when you use AI that what you input into that system is accurate. And you must have those type of filters in the background. So again, coming back to the human side, a person that understands the technology and understands the chemistry is always critical, because that will enable you to differentiate whether your data makes sense or not.
Exactly, thank you. And do you also have interdisciplinary collaborations at CECIL?
Yeah, so I think that's one of the points that I think is quite critical. So what we've learned is, for example, in our catalysis development, to have a process engineer, a mechanical engineer part of that process, having the statistical person enabling your large data set to become a usable format, and then the modeling done by the engineers. That multifaceted team makes the best. So diversity is actually what you need within any development. And then even recently within operations, what we've done is really enabling the analyzer department, who's really mechanically focused, and then incorporating them with people that's writing our operating programs, so that there's cross collaboration with them as well. So I would say multifaceted team, multidisciplinary teams are critical for any industry.
Yes, thank you. Yes, diversity is key in overcoming the challenges we are facing in analytical chemistry and advancing our field. So thank you for that, Alta. Now that we've discussed the evolution and challenges, let's now shift our focus to the future of analytical chemistry. We see trends in the miniaturization and portability of analytical instruments, as you've both mentioned, enabling on-site analysis for applications such as environmental monitoring, food safety, petrochemical industry, point-of-care diagnostics, etc. So Alexandra, what emerging trends do you see shaping the landscape of analytical chemistry in the coming years? And how can we harness these trends to drive positive change and innovation in the field?
Yeah, I already mentioned it, so I think it's really the community, or also as I mentioned it, so the communication between all the people. And yeah, there must be a better collaboration between R&D in industry with the analytical. So and also I think we also mentioned it already, the part with lab analytical and process analytical. I think it's also a really interesting and really important part, where we definitely need to go further and find some new solutions. And yeah, that all this R&D application and routine labs, process analytical lab, this must be or should go hand in hand and not side by side. So this is the key, I think.
Thank you, Alexandra. And Alta, for miniaturization and portability, we will get real-time decision-making, improving efficiency, decentralizing testing, and monitoring that empowers others like communities and so on. It can also free up human resources. So in terms of SASL, is this something that you use? What has been your experience with real-time decision-making and also decentralization of the use of instrumentation?
Yeah, so I think one of the needs in our space is really, as you say, fence line community, environmental compliance and monitoring of the emissions in our fence line communities. That's one of the key focus areas for us at the moment. And when we speak about evolutionary trends, I think as part of what the multifaceted, so I know one of our universities are focusing on 3D printing of different capillary systems for the GCs. And that type of thinking is what is important for us to basically expand quicker. I think we need to respond quicker. What we find internally in our labs is the fact that our equipment is old. And what I realized, to stay ahead, you actually need to basically build your own system quickly through the emerging technologies like 3D printing, etc. So again, if you free up the human capital, let's call it capital, you can actually enable them to basically, the younger generation is so quick with computer programming and incorporating that within analytics. So yeah, there's so much you can do if you really stay on the forefront with using, let's say, 3D printing and printing your capillaries and then expanding that to your other analytical fence line monitoring, etc. So I think that's where we need to shift our minds. The days of where you're going to purchase a piece of equipment and you will be able to stay ahead, it's more to do with your fundamental understanding and knowledge and how you can use that together with building your own kit.
Yes, so basically saying the advancements like 3D printing, advancements in data analytics, machine learning, artificial intelligence will continue to revolutionize data interpretation, pattern recognition, and so on in analytical chemistry, and revolutionize analytical chemistry as a whole, and perhaps bring in the society, with portable instruments, miniaturization, and so on. So empower the people, empower your communities, and in this way, perhaps ensure that our environment becomes more safe and sustainable. So Alta, can we stay ahead of the curve and adapt to these changes, or are we going to just get pockets of industries that actually stay ahead?
Yeah, so I think webinars like these and yeah, we spoke about your course at the beginning of when we met. But what I'm thinking of is, and this is why collaboration and communication is so important. I think in the past, we kind of protected our spaces to remain ahead of the curve. But while you spoke, I thought about, like, if we look at our communities and fence line communities and looking at the impact of our emissions, and staying ahead of the curve means for me also enabling the community to measure. So what we have is these points emissions monitoring stations, but you can link that with an app. You can link the data so that the community itself has access to your data. So I think, to answer your question, we can only stay ahead if we are open for change. and if we are willing to collaborate. So collaboration is key. And we're starting to see more and more of that. One point I wanted to mention earlier on is we're also finding that companies that supply equipment are open for collaboration. So we have several systems in our environment where we said we want to combine a VUV with a GC. Can we do that? How would we do that? How would the sampling system look like? And through that collaboration and with limited capital, you can then expand your analytical capabilities.
So Alexandra, as Alta stated, prioritizing interdisciplinary collaborations, fostering knowledge exchange, and investing in education of not just the personnel at your industries, but of your communities is critical. So what are your thoughts on this, and how does it relate to DAO?
Yeah, I think it's with the DAO, it's nearly the same. So I think, yeah, we need to be flexible, open-minded, and yeah, we must focus on how to solve the problem and not only what the device can, so, or the capability of the tool we have. So we have to think further and, yeah, let's say open-minded. Or as I mentioned, before this meeting started, I'm in Munich at the moment. Here is the Analytical, this is a conference, and here are all the analytic vendors, and they present their stuff, what they have. And yeah, it's really interesting also when you think of all the new stuff that is coming, and that is not really, so it's still in progress. When you think of microplastics or PFAS, these are all new topics that are coming, and yeah, we have to be focused on this, and we have to be open-minded and think further than what I have one device, maybe I have to couple devices and such things. So there are really interesting things and approaches, ideas. Yeah, and you have to be always on top there.
Yeah, Rosilla, if I can come in here, it's really a thing of what I'm always preaching to my space is understand the research question or understand the problem, and then you start with the analytical solution. Because we can think. That's what we're trying to do. So if you understand what the research question is, you can really delve into the advancements, the research, the really the front end of analytical. We should really steer away where our clients or our processes come and say, we think you should use this technique. We should rather ask, what is your question, and then bring our solution.
And perhaps developing that metacognition and lateral thinking. So thinking out of the box and not just being mainstream. I think that's critical.
Yes.
Because people generally tend to do what they're told and do what others do. So it's kind of apprenticeship of observation. So you do what you've seen.
Yeah.
We must develop thinkers who do what's different, looking at the uncertainties of things and developing new ways of thinking. Don't you think so, Alta?
Exactly. And if you think about the advantage analytical scientists have, is they have the breadth actually of what's happening within, let's say, SASL. So they can actually bring the forward thinking because they have seen in many places, or they've worked on multiple projects. So yeah, the lateral thinking, I think, is key, and to stretch people and to really challenge each other to think like that.
Yeah, I think here in our labs, it's also so that I think Alta also mentioned it before, so that we do not have one lab technician and he is doing the titration and the other one is doing the ICP. And so we want to do that. They are open-minded for all their stuff, and that a lab technician can handle everything they have in the lab. And I think this is also helpful to motivate the people when they see other things and not just their one device. And yeah, then they are working just with this device, and then they do not think out of the box anymore because they have just their one device. And when you look that they are, that there is a kind of challenge because they have to know everything in the lab, and then it's more helpful, to motivate them and to have the right questions and so on. I think this is important for the lab techs and for the future.
And looking at more hyphenated techniques. So as you're saying, there's different techniques working in their little silos. And we do have hyphenated like GC, MS, but perhaps bring in other techniques, I think you've touched on it, Alexandra, where we have a lot of techniques that are combined together that improves efficiency, accuracy, and so on. And these are perhaps innovations that we need to look at, and perhaps us as academics, we need to develop this kind of thinking.
Yeah.
And that's what, not to market the course so much, that's what we do in our analytical chemistry and measurement science course. We give you the breadth and the depth of a technique. We touch on the cutting edge technologies within the technique, and then we basically empower you and build capacity so that you can go out and be productive in your industry and think laterally.
And I think, that's the point. I think it's have the in-depth fundamental understanding, but have the ability to know that you can broaden and combine multiple techniques in different ways.
Yes, so we do touch on the fundamentals and advanced techniques, and then we also do the simulations, because we are an online course where we train you how to troubleshoot, having experienced different scenarios that you wouldn't necessarily experience in a lab. So you must be able to overcome different kinds of challenges, and that's to develop your metacognitive abilities and develop so that you think out of the box. Any last words from you, Alexandra?
No.
So thank you to our panelists for your insightful contributions to today's discussion. It's really been very enlightening. I encourage everyone to continue their exploration of analytical chemistry and to remain committed to advancing scientific knowledge and discovery. And through our discussion, you can see why there's a lot of challenges that we experience in today's world, and we need to address at the same time with the advancements in technology, artificial intelligence, and so on. We really need to stay ahead of the curve. So together we can shape a future where analytical chemistry continues to drive innovation, solve these complex challenges, and improve our lives. So thank you to everyone. Xavier?
Yes, thank you very much. Thank you, Rashila, and Alexandra, for this fascinating discussion, really. So we are now going to open the floor to some questions. Please, we will only use the Q&A function and the chat box. So please write your questions in those tools, the Q&A function or the chat box, and we'll try to answer a couple of questions. While you think about your questions and type them, I just want to take a quick minute to briefly introduce our analytical chemistry and measurement science course for those of you who might not know it yet. So as Rashila mentioned, it's an online part-time course, and you can choose between different qualifications and complete, for example, a full master's in as little as around 2 years, or go for a postgraduate diploma, a postgraduate certificate, or simply a CPD module that you can complete within 3 months. What's good to know is that there is a clear line of progression from the postgraduate certificate to the postgraduate diploma and to the master's afterwards. So, for example, if you don't originally meet the requirements for the master's, we do consider professional experience, and you may start with a postgraduate certificate and get upgraded. The master's is made of 6 taught units. 5 are mandatory and 1 is optional, and you have different choices for the options. So 6 taught units and a research project, which can be practical or theoretical for the master's. I invite you to look at our course webpage. I'll put that in the chat in a minute, to have the link to the webpage, where you will find more information about the units that are offered and what they cover exactly. All taught units and assessments are delivered online. So it is a part-time course specifically designed to be delivered online. This means that you can really organize your studies around your work and personal commitments. And it's also important to know that there is no final exams. The assessment is continuous throughout your studies. We recommend that you spend around 20 hours per week on your studies. This includes watching lectures and video content, joining live tutorials, reading, participating in discussion forums. There is a variety of different activities you will engage with. So once again, please look at our webpage for more detailed information. On the course webpage, you can register to get more information by email about the course or the events we organize. And last thing to mention is that our next intake is next September. And if you apply on or before Monday, 19th of May, you can get the 10% early application discount. Once again, I refer you to the course webpage where you will find more information about fees, discounts, and scholarships available. So just to finish, the applications for the course are now open for next intake in September. And to secure your place on the course, I strongly recommend that you apply sooner rather than later. So let's start the Q&A session, and let's check. We've got some questions coming up in the Q&A function. So the first one is comes from Chenjerai, and it's about regulation. So we were talking about regulations earlier. That member is asking, is there an analytical chemistry board or regulatory body responsible for overseeing the field's activities? And if so, what measures has it implemented to ensure that analytical chemistry keeps pace with the demands of today's world? Is it something?
Maybe I can start, and then we can move on to Alta, who can talk about the petrochemical industry, and Alexander, who can speak on Dow. But we do have organizations like the International Union of Pure and Applied Chemistry, that's IUPAC, and the International Council for Harmonization of Technical Requirements for Pharmaceuticals for Human Use, that's ICH. They provide platforms for international collaboration, standardization, and harmonization of analytical methods and practices. There's other platforms, maybe Alta, you could
in South Africa, I can speak for South Africa, we've got, you get ISO accredited, where it's basically when you do analysis and you are accredited to do, let's say, elemental analysis. So what that board does is you basically get reviewed on ASTM standards that they send you. You do the analysis, and when it's within a band, you get accredited. So that's the only type of regulation that we have in our space.
You'd also get the US EPA. It depends which country you're at. There are regulatory authorities in different countries. Alexandra, in Germany and Dow?
Yeah, we have also different. So also in Germany, we have different authorities. So in Lower Saxony, we have the NLWKN, and they have, for example, they look for wastewater, and because we take cooling water from the Elbe River, and so there's the authority, and they come and they say what we have to fulfill for regulatory requirements and so on. So it's, as you said, for each country, there's an authority, and they give the way to go.
Great, thank you. Another question that we have received is from Otis, who's asking, for the hydrogen used in GCUs, besides the instrument parameter changes, what is the impact of changing this in terms of issues from a safety and risk assessment perspective? They found that safety services do not want them to switch due to the explosive risks, despite Agilent and Shimadzu stating that there isn't a significant risk.
Yeah, I know. There's really an application where they told them that there's no risk for hydrogen. I know it, and we did risk assessments because of the change from helium to hydrogen. And yeah, we thought of ventilation in our lab, so the air exchange and such things, and where is it possible where hydrogen can left my system for the GCs. And for example, you have your split, and there is the most hydrogen that is leaving the system, but there we had no issues because of our as I mentioned, the air exchange in our lab, the ventilation, so there's no risk. And I think each lab, when you use hydrogen in your lab, you have to you must have such an emergency button for hydrogen, that all the gases are off when something happens in the lab, a fire or something like that. So we saw that there is no risk in our labs. So maybe this helps when you have a look of your air exchange and your ventilation, and have a look of the environment, and then also can maybe have the same conclusion here. Thank you.
Thank you. Another question is regarding spectrophotometer. So from Adeniyi. So looking at the world of analytical chemistry, what is the main focus when it comes to the area of using the equipment such as spectrophotometer? I don't know if it's a question.
Well, maybe I can just start by saying that the development of state-of-the-art analytical instruments such as chromatographs, spectrometers, sensors, has enabled researchers to analyze complex samples with unprecedented sensitivity and specificity. So innovations such as HPLC, GCMS have expanded their analytical capabilities and the scope of applications in various industries, as we've seen at Sasol and pharmaceutical industry, petrochemical industry, agriculture, and Dow, and environmental monitoring. So I'm not sure what the question is asking, but with these advancements, we really have moved forward in terms of analytical research. Perhaps maybe Alta and Alexandra would like to expand on that.
Yeah, so in our space, we use spectroscopy specifically as what we call our front line of defense. So when we need to have answers quickly, we use our infrareds, our UVs, our Raman, because we've learned that you can get a good answer for minimum effort. So I think that's where we use that to a large extent to save cost and resources.
Thank you.
Yeah, thank you. Maybe a last question I have, it's regarding lateral thinking and metacognition skills. We were talking at the end of the presentation. Do you believe that there is, the question from Otis is that, do you believe that there is an inherent advantage on this front by hiring neurodiverse staff in the industry?
I'll leave that to Alexandra and Alta. Firstly, how would you gauge who's neurodiverse?
Yeah. Yeah, so obviously in industry, I think it's very difficult. I think that's the advantage of being in academics, in terms of you've got access to diverse thinking, and that's why I made the statement of collaboration and even sessions like this. In industries, it comes down to the bottom line. So you need to really be able to see what advantage you will have, and yeah, how would you define it is a good question. Yeah, it's all about the bottom line actually in industry. So you would really need to see a business case for employing people, neurodiversity.
Well, I think that's all for the moment. So I'm conscious of the time, and so I think we are arriving at the end of the event. I will just launch a quick poll for our attendees. Please feel free to fill that in. Thank you again very, very much, Alexandra, Alta, and Rashila, for sharing your perspectives and experience. I think it's been very, very, very valuable. Thank you for your participation. Thank you for the audience joining us today. Feel free to get in touch about how to apply to the course, or if you have any further question, you can email me at studyonline@manchester.ac.uk. We will finish here for today, and so thank you again for joining us, or for those watching back this event. Bye for now.
Thank you.
Bye.
Bye, and thank you.
Bye.